Hello, I'm Mark Gelfo, and welcome to the first in our greenWORKs series entitled Buildings Use a Lot of Energy and Water, Reducing Demand. This is the first series, and other modules in the series will include subjects such as energy auditing and benchmarking, how to use the Energy Star Target Finder to do benchmarking for a building's energy performance. We'll talk about retro commissioning and measurement verification as ways to reduce energy on an ongoing basis. We'll be talking about LEED for existing buildings, operations and maintenance, and how that system can fit into helping a building reduce its energy consumption, and we'll have some case studies along the way. But starting off with Module 1 here, we're going to be talking about the fundamentals of energy use and energy demand in commercial office buildings. We're also going to be talking about water and water reduction in commercial buildings, as well as strategies on how to reduce how much energy and water buildings use, and we'll also touch on renewable energy sources and how they play into the conversation about reducing energy demand and moving buildings towards net zero. So let's start with an overview about energy. I like to say that buildings use a lot of energy, more so than most people think. Commercial buildings in the United States are the #1 user of energy that is produced and the #1 producer of CO2 emissions. Not transportation, not heavy industry. It's commercial buildings that drive energy performance of the U.S. 39% of all energy used in the United States comes from commercial buildings, and it consumes almost 3/4 of all the electricity that is produced. So that's why this is such an important topic, and we want to focus on reducing those numbers one building at a time. This table comes from the Energy Information Administration that summarizes all energy used in commercial buildings in the United States. And as you can see from the pie chart, heating, lighting, cooling, ventilation, the HVAC and refrigeration account for the majority of energy used in commercial buildings. This is all energy, so that includes not just electricity, but natural gas and any other energy sources that go into a building. So when you combine HVAC and refrigeration, almost getting close to 60% of the energy used in buildings is accounted by that, 20%, 21% in lighting, followed by what we call process energy, which includes plug loads, things that plug into outlets, things like kitchen equipment and any other non-regulated process loads, and then water heating. So if we look at that same data, but just as electrical use, electricity, taking out natural gas and other sources, lighting jumps to the top as the single largest piece of the pie. But again, when you combine all of the heating, ventilation, air conditioning, and refrigeration numbers, it's 42% of all the energy, all the electricity that goes into buildings is used to heat and cool it, and then almost another 40% in lighting. So these are the areas that we generally talk about targeting when we're talking about reducing a building's energy consumption. This is a map of the ASHRAE climate zones, and the only reason I included it here is to bring up the point that energy needs and strategies are different in different parts of the country. Here in Florida, we're in what's classified as a hot and humid climate, which seems pretty obvious. So our targets and our strategies in Florida are going to be different than, say, they would be in the Northeast or the Pacific Northwest. So why do we care about this? Well, like I said, buildings are the #1 user of energy in the United States, so if we can minimize that through one building at a time, then we're making a big impact. The extraction of energy and the production has obvious negative impacts on the environment. Refrigerants used in cooling systems can have negative impacts to the environment as well through ozone depletion, as well as people. And it costs a lot of money. We spend a lot of operating dollars in buildings on energy, on electricity, on water, and everybody wants to save money. So throughout this series, we're going to be talking about those types of strategies and things like, do you know what your building's energy use intensity is, EUI? Because the first step in trying to reduce energy consumption is knowing how much energy you use and where you use it. That also is where Energy Star comes into play, which we'll talk about in later sessions. So from a design standpoint, when we're designing new buildings or renovations to buildings, it's very important that we establish energy goals for the project, to sit down with the owner and the people who are going to operate the building and decide what we want to target as far as energy goals, whether those be in a % reduction below code or below a baseline standard, or if we want to target a certain EUI, energy use intensity, in a kWh per square foot or kBTUs per square foot. But whatever the goal is, it's important to establish that so the entire design team, architects, engineers, even get the contractor involved, operations people, everybody can be working towards those goals from the very beginning. And then we can look at things like the size of the building, its massing and orientation of the building to take advantage of free energy sources like the sun for daylighting, or if we were trying to take advantage of heat gain, things that are very simple to do but require the entire design team to be bought in and strategize. Using energy modeling, building simulation modeling to model different options. What happens if we change the insulation to this type, or we change the building HVAC system to this type, or we reduce the lighting power density by this much, or we change the windows to this. We use energy modeling to track those different options, what the impact they're going to have on not just the energy performance of the building, but also on its operating cost. We want to use high-performance HVAC systems where we can. We want to maximize the efficiency of the envelope through good windows and insulation and roofing. We also want to not forget about the plug loads, the things that are plugged into the outlets in the building, because as we reduce the HVAC and the lighting consumption in buildings, then that piece, the plug load piece of that pie, becomes a little bit bigger and the next place to really target. But when the design's done and the construction's done, that's certainly not the end of the story for a building's energy performance. It's really just the beginning. The building can be designed and constructed to be the most efficient building in the world, but if it's not operated the way it's intended or operated efficiently, then we haven't made much of a difference. So in later sessions, we're going to be talking a lot more about existing buildings and energy auditing and retro commissioning, knowing how much energy your building should be using, tracking if it is or not, and then looking for opportunities to reduce its energy consumption. A lot of those get into the very simple things like we call low-hanging fruit, like simple envelope issues. If the building is not sealed properly, then our air conditioning or our heating is just leaking out into the neighborhood. Lighting controls and HVAC control strategies are some of the easiest things to tackle and the most common things we find when we go into an existing building and start really digging into how the building's operating from an energy auditing or retro commissioning standpoint. And again, measurement verification is one of the biggest things that we can do in existing buildings to minimize their energy impact. That's tracking how much energy the building is using and where it's using it so that we can target energy conservation measures. Information is power. Renewable energy is also part of the conversation. And when we talk about on-site renewable energy, we're talking about sources that produce energy on the site, things like photovoltaic and wind power and hydroelectric, geothermal, solar power, biomass, and a host of others, but those are the most common ones that we talk about. Producing renewable energy on your site can go a long way to minimizing the impact that the building has on the environment. So I always like to start with a clarification, description, and definition of solar or solar thermal versus photovoltaic or PV. A lot of times we tend to say solar to cover either one of these terms, when really what solar thermal means is when we take the sun's radiation energy and transfer that into heat, typically by heating a liquid, water of some sort, through a heat exchanger. So we're using sun's energy to heat water and to do something useful in the building, usually domestic water heating. Photovoltaic is where we take the sunlight and through the crystalline structure of the PV panels, the photovoltaic panels, that sunlight is converted into electricity, which is tied right into the building's electrical system. Maybe it's stored in batteries for future use. They're both very good strategies, but they are different. Solar thermal tends to have a quicker payback period and be a little less expensive on a first cost basis than photovoltaic, but there's only so much you can do with it, not too much beyond domestic hot water heating, whereas PV might have a little longer payback, although those are coming down, but we are offsetting the electricity use that's coming into our building. When we talk about net zero buildings, we're basically talking about buildings that produce as much or more energy, if we're talking about net zero energy building, than it consumes. So the building produces more energy than it's consuming. And that can be measured in a number of different ways. It doesn't just have to be electricity use. We can measure it in the total site energy, or by cost, or from the source, or in emissions. And it also doesn't mean that the building is not connected to the grid. You still have connections from your local utility company most times, and then sometimes during the year you may actually be using energy from the utility company, but in other times of the year then you may be exporting more energy than you consume, and then the net effect over that year's time frame is that you're producing more than you're consuming. When we strategize about how to do net zero buildings, first, we want to make the building as efficient as possible by reducing its demand, using efficient HVAC and lighting sources, daylighting, things we talked about a little bit earlier. And then after we've squeezed every possible watt and BTU out of the building, that's when we start applying our renewable energy sources. There's no reason to oversize the PV and solar systems or wind or whatever if you don't have to. If you can make the building use less energy in the first place, then we can buy less renewable energy and still get the same effect. Energy Star, we're going to be talking about Energy Star more in later sessions, but Energy Star is the database by the Department of Energy that helps us benchmark a building's performance. Basically, with inputting just a little bit of information, a little bit of data about the building, how big it is, what type of building it is, how many people use it, and where it is, the Energy Star database compares that building's actual energy consumption from your past 12 months of utility data, compares it to similar buildings in your area, and then benchmarks that score on a score of 1 to 100, 100 being the most efficient building that's in the database, and 0 or 1 being at the very far end. It's a great tool to get a feel for where your building compares to other buildings and what the potential might be for saving energy in your building if you compare it against an average building or an Energy Star building that has a score of 75. But we'll be talking about that in much more detail in future modules. Real quickly, I wanted to mention the 2030 challenge. If buildings are one of the major problems to the energy consumption and environmental impacts, then buildings can also be the solution. So the 2030 challenge is is just that. It's a challenge. It's a pledge that architects and engineers and designers take to help drive the energy performance of their buildings down way beyond what they are right now, with the goal of achieving net zero in the year 2030. If we keep pushing the envelope and keep track of how our buildings are actually performing and how we're designing them, then we can make a bigger impact. So it's a stair-stepped type of goal. Through the end of 2014, the goal for 2030 Challenge participants is to design their buildings to achieve a 60% energy use reduction compared to that CBEX or Energy Star database that we just talked about. And then in the following years up through the year 2030, we stair-step that goal to 70%, 80%, 90%, again with the goal of being carbon neutral, using no fossil fuels in buildings by the year 2030. By reducing the energy use in the buildings and then applying our renewable energy sources, we're also allowed to use purchased renewable energy credits to help offset some of that. It is a very lofty goal, but I believe that it's very important to focus on these things, because if we don't push the envelope, then we're not going to make any progress whatsoever. Let's talk real quickly about water, because water is another natural resource that we use a lot of in buildings. There's only so much water available, and if we weren't focused as a nation so much on energy, we would definitely be talking more about water. And there's a beginning of a water crisis in this country, and we need to start doing something about it. Plus, water and energy usage are directly linked. We use a lot of energy in the transportation and the processing and the pumping of water to our buildings and to our houses. Again, it costs a lot of money, and we can save on our utility costs through some simple water use reduction strategies. If we know how much water we're using through benchmarking and establish some conservation goals, that can go a long way towards making an impact on the amount of water we use. Again, measurement and verification of our water. So we're going to talk about three main areas of water: indoor water, outdoor water, and process water. Those are the areas to attack. Real quickly, some definitions about water. Make sure we are all on the same page from a term standpoint. Potable water is what we're trying to reduce the use of in buildings. This is drinking water, especially drinking water that we are not using for drinking purposes, like flushing toilets, and it goes down the drain. Gray water is water that we can capture from other processes and reuse after some cleaning and filtration to do some good things in our buildings, whether it be irrigation or flushing toilets or something like that. Black water and wastewater is the water from our toilets that go to the treatment plants that we're generally not going to do a whole lot with. Stormwater is the water that falls onto the site that generally we try to get away from the site then if we have too much impervious surface through stormwater. And the Energy Policy Act of 2005 is the federal guideline that basically sets the benchmarks for the performance of our plumbing fixtures. It's EPACT that tells us how many gallons per flush a toilet can be, or how many gallons per minute a sink is allowed to use basically by law. So with that, let's talk about indoor water use. This is water that we use in our bathrooms and plumbing fixtures for things like sinks and toilets and urinals and showers. And the strategy really is twofold. If we can reduce the flow that these fixtures use, so use low flow or efficient fixtures that, for instance, would use, instead of 1.6 gallons per flush for a standard toilet, then if we specify and install a low flow toilet that uses 1.28 or 1.1 or even 0.8 gallons per flush, we're saving a whole lot of water. Urinal showers, lavatories, and sinks, you can see the requirements from EPAC 2005 versus some of the more efficient fixtures that we can use. So, a waterless urinal or a 1 pint, 0.125 gallon per flush urinal is going to save a lot more money and water than a 1.0 gallon per flush urinal. The other thing we can do is use non-potable sources of water, captured gray water that's reused, or captured rainwater, for instance, to do things like sewage conveyance, flushing of toilets, things that we don't need to use drinking quality water for in our buildings. It's also a very good strategy to install meters and sub-meters on your different water processes in your building, not just the meter, the main water meter on the outside of your building, but how much water are we using either for these sources or in this wing of the building. The more sub-metering and the more you can drill down in your usage, the more of an impact you can potentially make. Knowledge is power. Outdoor water is simply the water we use for landscape irrigation. Again, there's a couple strategies that we can use to reduce the amount of water. We can put in local, native, adaptive plants that don't need to be watered at all, that survive and thrive on natural rainwater, the water that falls from the sky that's free. If we install the right plants, then we don't have to put in any irrigation at all. And where we do have to put in irrigation, we can reduce the amount either by putting in more efficient technologies, drip irrigation that's 90% efficient as opposed to spray fixtures that are 50 or 60 or 65% efficient, reduces the amount of the water that just gets evaporated. And we can use non-potable water sources for irrigation. Again, that gray water or captured rainwater that can be used and captured and then reused for our landscaping. And again, knowing how much water we're using through sub-meters on our irrigation system can help give us the information we need to know if we're spending more water than we need to outside of the building. And then lastly, processed water covers a number of topics that basically aren't covered by EPAC. So things like industrial processes for heating and cooling towers and boilers and chillers, clothes washers and kitchen equipment and dishwashers. In some medical applications, we have processed water that's used for cooling of equipment. So this is a major area that doesn't get talked about a lot of water usage in buildings that we need to be targeting. So we can, again, do some simple things like make sure that we don't have any once-through uses of water for cooling or for cooling processes. If we can use non-potable water for things like the boilers and chillers and cooling tower makeup, anything that doesn't need to have potable water, we can use alternate sources. Of course, we can always put in more efficient fixtures, especially when we get to kitchen equipment and clothes washers and dishwashers, more efficient appliances that just don't use as much water in the first place. And again, sounding like a broken record, installing sub-meters on our different processes so that we know how much water we're using in each one, and we can target those for reduction. So that in a nutshell is our overview of buildings use a lot of energy and water. I hope you got some strategies on how to reduce the energy usage and water usage in your buildings. Join us for the next session, which is titled Finding the Skeletons, focusing on energy auditing and benchmarking. Thank you.